In this video, we will factor polynomials with 4 terms using the grouping method. So remember, factoring is a way to break down a polynomial into its parts. I want to break that polynomial down into the things we would have multiplied together to get that original polynomial. And our next way to do that is going to be grouping. So notice in our example here we have 4 terms: x cubed, 7x squared, 2x, and 14. Those are our 4 terms that we're starting with. In order to factor by grouping, the first thing we're going to do is group. We have to group the first 2 terms together and the second 2 terms together. This allows us to look at those groups separately, and we're going to use what we already know how to do, which is GCF. So we're going to take out a greatest common factor from each grouping. In the first group, x cubed plus 7x squared, I notice they have an x squared in common. In the 2x and 14, I notice they have a 2 in common. So in the first group, I'm taking out that x squared. So x cubed divided by x squared leaves me with x. 7x squared divided by x squared leaves me with 7. Then I'm taking out a 2 from this second group. So 2x divided by 2 is x. 14 divided by 2 is 7. Notice here in the grouping and the GCF that we've done, those parentheses that we ended up with are the same. Hopefully this looks familiar from when we multiplied binomials. And we had those parentheses that were the same when we distributed. So we can take the first parts of each one of those groups, and that's going to become one of those binomials. And the second set will be the x plus 7. So when we factor this, we look at x squared plus 2 being that first binomial, and x plus 7 being that second binomial. The last step is going to be to check our work by expanding the factored answer that we got here. So remember, when we multiplied x squared plus 2 times x plus 7, we would distribute the x squared to the x plus 7, and it would look like this. And then we would distribute the 2 times the x plus 7, and it would look like this. Notice how that looks like our step 2 from above. Then if we were to finally distribute the x squared and the 2, we end up with the polynomial that we started with. So let's try this on a few more examples. Here I have x to the 4th plus 4x cubed plus 2x plus 8. So the first step is to group. So I'm going to group the first 2 terms and last 2 terms. My next step is GCF. So I look at this first grouping and notice I can pull out an x cubed. In the second group, I can pull out a 2. Notice once again that those parentheses are the same. Because those parentheses are the same, I can group the x cubed and 2 together to be the first binomial, and x plus 4 to be the second. Now, in order to check our work, I'm going to start from our answer, and then I'm going to distribute just like we would when we were multiplying binomials. So I'm going to distribute the x cubed to the x plus 4 and the 2 to the x plus 4. When we write out that distribution step, notice how that looks like this blue step up here. I'm multiplying the x cubed times that second binomial. I'm multiplying the 2 times that second binomial. Then when I distribute, I get x to the 4th plus 4x cubed plus 2x plus 8, which is our original polynomial that we started with. In this example, our first step is to group. So I group the first 2 terms together and the second 2 terms together. Next, I need to pull out GCFs. So in this first group, I notice I can pull out a 3 from the coefficients and an x squared from the variables. In this second grouping, I notice that they have a 2 in common, but remember, I want the parentheses to look the same. So in order for our parentheses to be an x plus 5, I'm going to need to pull out the negative 2. So when I divide out my GCF from each group, I'm going to end up with x plus 5 in those parentheses together. Now I can bring together my 3x squared and negative 2 to be that first binomial, and x plus 5 to be that second binomial. Now to check our work, I want to distribute that 3x squared, 2x plus 5, and the negative 2 to the x plus 5. When I do that, notice once again how it looks like that blue step from our factoring. Then when I distribute, I get our polynomial that we started with. This problem is on your own. Make sure you follow the steps and check your work. So we're starting with 8x squared plus 12x plus 2xy plus 3y. I need to group first. Now look for the greatest common factor. From 8 and 12, I can pull out a 4. From x squared and x, I can pull out an x. From 2xy and 3y, I can only pull out a y. Notice how this forces those parentheses to look the same. Now I can bring the 4x and the y together, and 2x plus 3 is my second binomial. To check our work, we're going to distribute the 4x to the 2x plus 3 and the y to the 2x plus 3. Notice again, this looks like our blue step from above. I'm distributing the 4x to that second binomial and the y to that second binomial. Now when I distribute, I get 8x squared plus 12x plus 2xy plus 3y. This next problem is on your own. Follow the steps and check your work. Here, our first step is to group. We group x squared y and 3x squared together, and negative 7y squared and negative 21y. I see my GCF in the first group is just x squared, so I'm left with y plus 3. So when I'm left with y plus 3, I know my second set of parentheses need to look like that. So in order to force that to happen, I know I'm going to have to pull out the negative 7. They also have a y in common. Then I bring together my factored form, and now I need to check. So I have x squared minus 7y times y plus 3. Distribute the x squared and distribute the negative 7y. X squared times y plus 3 minus 7y times y plus 3. Once again, notice the connection here. And when we distribute, we get our original polynomial. This next problem is on your own. Follow the steps and check your work. This next problem is on your own. And then this last problem on your own.